Okay, so do you receive my email? So quiz 8 is today. So don't forget to take the quiz. The quiz covers sessions 7.1 to 7.5. The review session virtual is gonna be on Wednesday from 8 to 10 p.m. So I will also make a recording and we will go over our practice final exam. And the final exam is on next Wednesday, December 14th from 1 to 3 p.m. This is a practice final exam and a solution. And this is a final formula sheet that I will print out for you. It includes the blanks, like the exam 3 formula sheet, and also the new formulas we learned in chapter 7. Okay, everybody? And yeah, please do your practice exams multiple times. First use pencil and then use a red pen to correct your work and also estimate your total score. So, and this week, this Friday is the last day I accept late work. So all the homework, all the practice exams, except the practice final exam is due on the final exam date. But all the other stuff, yeah, the exam correction and wrapper, please submit by this Friday. Okay, everybody? And if you can submit earlier, that's better because I will grade your work. And if you miss something, you see the notes like why did you miss? Maybe you forget to estimate your total score on your practice exam. That's why you lose 1 point. So you can resubmit and gain those points back. Okay? But if you submit your work on the last day and I don't have time to grade it, then you have no chance to resubmit to gain your points back. So please submit those earlier, guys.
When are our notes? When do you want those?
Oh, okay. So come to my office hours and then show me the notes. It just take me 5 minutes to go through it. Oh, okay. So today I will be in my office from 3:20 to 5.
Okay.
And my other office hours, you can go to our like course website. Uh, so yeah, Monday, Wednesday, 3:15 to 4:45, and I usually stay until 5. And then Friday as well. Friday I might leave earlier, and then Tuesday, Thursday from 11 to 12 and 2 to 3. Okay. If you're not available, email me. What time are you available? Please just send me your schedule and day. It just takes me 5 minutes to go through your notes. Okay, everybody? Mm-hmm. Yeah, if you take your notes for electronic, you can like bring your laptop or your iPad to show me your notes. Okay. Yes, and the evaluations. So our course, the current response rate is 64%. So everybody will get at least 0.2% extra credits. So yeah, if you haven't filled the survey, please help me to fill it out. Thank you so much. And you can see my Calc 2 class, I got 92%, and Calc 3 class, I already feel out all. Yes. So, okay. And thank you. All right. Yes. And, oh, okay. So, study sessions. So, besides my review session Wednesday, tomorrow from 6:30 to 9 p.m., I will have this study sessions. Okay, so it's open to all Indiana Tech students. Uh, then it's in Andover Commons, the Science Conference Room. Uh, so yeah, snack and music will be provided. Okay, so if you have time on Tuesday night, you can bring me a note as well. Yeah, and you can come there, come to yeah the sessions, and then maybe do your practice exam, do your homework, do your notes, and then if you have questions, then you can ask me. Okay, so I will be there. Dr. Boyce will be there. Dr. Good will be there. So Dr. Boyce, physics, psychology professor. Dr. Good, biology professor. Dr. Brownie, English professor. Okay, and Sunday, yeah, Sunday we have another study session, but I won't be there. But Dr. Ortega Cantor-Gamboa will be there. He's another Precalculus professor. Okay, everybody. Mm-hmm. Okay, so yeah, so today don't forget to do your quiz. And today we're gonna talk about session 8.1, non-right triangles. So right triangle means we have one angle that is 90 degrees. Okay? If we have right triangles, then we have all those trig functions, right? Sine, cosine, tangent, cotangent, secant, cosecant. Then if we know an angle and a side, then we can figure out the size of the length of the other side and the other angles. Okay? But what happens if our triangle is not a right triangle? Okay? Then we need the law of sines and the law of cosine. Definition: an oblique triangle is a triangle that has no right angles. So no angle is 90 degrees. To solve an oblique triangle, there are 4 cases. We know to solve means we want to figure out the angle, the degree, okay, of all the angle, and we need to figure out the length of all the sides. Okay, let's solve a triangle. So the first type, we know 2 angles and any side. By the way, if you know 2 angles, then you know all 3 angles, because the sum of those 3 angles is 180 degrees, right, everybody? That's why if you knew 2 angles, then you know the other one. The other one is 180 degrees minus the sum of the first 2, right, everybody? So the first case, we know 2 angles and any side. So that's why angle, side. Okay? Then you want to find the remaining angle and the other 2 sides. Okay, everybody? So angle, side. Second case, we know 2 sides and an angle opposite one of them. So this is SSA, as ambiguous case, because it depends on the angle. We have different cases. So this is hard. And then the third one, 3 sides. We know the length of those 3 sides. We don't know any angle. Okay, so this is SSS. And then the fourth one, we know 2 sides and their included angle. The included angle means is the angle between those 2 sides. Okay, so SAS. The first 2 cases can be solved using the law of sines, whereas the last 2 cases require the law of cosine. The law of cosine we covered in sessions 8.2. Okay, which is, we're going to talk about that on Wednesday. All right, so law of sine can help us to figure out angle, side, and side, angle. Okay, let's see. What is the law of sine? Okay, so we have the triangle. We have the angle ABC. We use capital letter to denote angle. And then we use small letter to denote the sides. So you put the opposite side corresponds with the same letter. So the opposite of this angle A is the side A. Is that okay, everybody? And then this side opposite to angle B, we call side B. And then this is opposite to angle C, we call side C. Okay, everybody? So it's the opposite sides. We don't use the adjacent side because look at this angle. We have 2 adjacent sides. We don't know which one you mean, right? But opposite side, there is only 1 opposite side. That's why we use opposite side instead of adjacent. We have 2 adjacents. Right, everybody? Okay. So the law of sine. Well, the pattern is very easy. We use the side over sine of the angle. So A over sine A, B over sine B, C over sine C. The law of sines tells us that all these are equal. Okay. Attendance. Right. Yes. This is the last week. Okay. All right. So let's prove the law of sine. Okay. All right. So this is a proof. So first of all, let's draw an And altitude. Okay, so draw altitude through point C. Okay, so draw an altitude through point C. You might ask, oh, why do we pick point C? Can we pick point A or point B? Yes. Okay, it's just a similar proof. You can pick any point and draw the altitude. All right, and then we get two right angle triangles. Okay, so let's call this is point D. Okay, so draw altitude through C and let's call this point D. And the triangle ACD is a right triangle. And the angle D is 90 degrees. And also the triangle CDB is also a right triangle. Is that okay, everybody? Yeah, so those two right triangles, they are triangle ACD and the triangle CDB. Okay? And now, in the triangle ACD, let's call this altitude is the height. Okay. So in the triangle ACD, angle A. Let's relate angle A and the side B and the H. You see, H is the opposite of angle A, right, everybody? And the side B is the hypotenuse. Can you see that, everybody? So this is angle A, this is B, and this is H. We know sine A is the opposite over the hypotenuse. And hypotenuse, the opposite is H, hypotenuse is B. Right, everybody? So therefore, we have H equals both sides multiplied by B. So we have B times sine A. See? Something wrong with it. Let me save. Okay, so H equals B sine A. And then in the triangle CDB, so let's draw CDB. Okay, this is B, this is C, this is D, and this is H, this is A. Can you see sine B? Again, opposites over hypotenuse. Opposite is H, but hypotenuse in this case is A. Can you see that, everybody? Oh, so we solve for H. H is both sides multiplied by A. So A times sine B. Oh, H equals B sine A is also equals A sine B. Right? So set them equal. We get B sine A equals A sine B. All right. Let's divide both sides by A and B. So divide both sides by AB. Then we have B sine A over AB equals A sine B over AB. Now you see here, B cancel. On the right hand side, A cancel. So we have sine A over A equals sine B over B. Okay? So similarly, we get sine A over A equals sine B over B equals sine C over C. Okay? Yes. So we sine C, we draw the altitude, then we can prove sine A over A equals sine B over B. And then if you do it through the A, draw the altitude, then you can prove sine C over C equals sine B over B. Therefore, you get the law of sine. Is that okay, everybody? Mm-hmm. Yeah, the pattern, very simple. Sine A over A equals sine B over B equals sine C over C. Or you can put them. If you put them all of them, you get the same thing, right? Therefore, you can use the sine over sine of the angle, or you can use the sine of the angle over the sine. Just make sure they follow the same pattern. So far, so good, everybody? Any questions about the law of sine? All right, let's do examples. Okay, so given two angles and one side, so that is angle, angle, side. We solve. So here, all right. So let's see. Okay, so this is a degree. Okay, so put the degree there. So we know angle, angle, side. The sum of three angles in a triangle is 180 degrees. Okay, so I like to call them names. So let's call this is A, this is B, and this is C. Okay. And then the side opposite to A is A, small a, and this is small c, and this is small b. So here we know angle A equals 15.1 degree. Angle B is 101.5 degree. Then angle C is then 180 degree minus those two angles. So 15.1 and 101.5. Can you help me to plug into your calculator? What do you get? Thank you, 63.4 degrees. Okay, so those are the three angles. Now we know the side C is 22.7 centimeters. Okay, so we want to find B and A. Okay, write down the law of sine. The law of sine tells us that sine A over A equals sine B over B equals sine C over C. We plug in all the numbers that we know. So sine A, what's A? Yeah, 15.1 degree over small a. Oh, we don't know small a. We're looking for small a. Yes, everybody? Equals sine B. What's B? Yeah, 101.5 degree. And then over B, we don't know B. We're looking for B. And then sine C. C is 63.4 degree. Over C is 22.7. Is that okay, everybody? Mm-hmm. Okay, we want to find A. So what is A? Well, what do we need? Okay, we want to find A. This is our unknown, and this one we know. Okay, so to find A, we need that one and that one. So this is the equation, but we have three expressions, right? So to find the A, we need sine 15.1 degree over A. Is that equal to sine 63.4 degree over 22.7? How do we find A? We can both sides multiply by A, right? Both sides multiply by A. Then we get sine, okay, so both sides multiply by A. Then this cancel. We get sine 15.1 degree equal sine 63.4 degree over 22.7. Okay, times A. And we want to get rid of this guy. So both sides divided by that. Then these two cancel. We have sine 15.1 degree over sine 63.4 degree equals A over 22.7. Right? We want to solve for A, so multiply by 22.7 on both sides. Yeah? Then 22.7 cancel. So A equals sine 15.1 degree over sine 63.4 degree and times 22.7. What do you get? Give me two decimal places. And make sure you use the degree mode in your calculator. What do you get? Thank you. 6.61. Okay, centimeters. Great. So that is A. And then next, to find B. Well, to find B, you use this guy. Right, everybody? You use those two expressions and you solve for B. This process looks like longer. Maybe you can use an easier process. Do you know cross multiply? Yeah. So you can cross multiply, then it means B times sine 63.4 degree equals sine 101.5 degree times 22.7. Yeah. So you can do cross multiply. Then you have B times sine 63.4 degree is sine 101.5 degree times 22.7. And you want to both sides divided by sine 63.4 degree to get rid of that. Okay, so put that in your calculator. What should be? Okay, so you both sides cross multiply and then you want to find the b. So carry on that. So both sides divided by sine 63.4 degree. What do you get? 24.88 centimeter. Thank you. Is that okay, everybody? So this is how to solve angle sine. Okay, so you first find all the angles, and then you plug in the law of sine to figure out what is unknown, what is known, and then you solve for the unknown. Okay. All right, next. Side A, the ambiguous case. Okay, if two sides and one opposite angle, side A, are given, three possible situations can occur. 1, no such angle exists. 2, one such angle exists. Third, two distinct triangles exist. So, okay, let's see. Consider a triangle in which we are given A, B, and A. So, side angle. Okay, let's imagine we know the side A, the side B, and the angle A. And then we draw the picture. So, draw the picture like that. So, what happened? Okay. So we know A is here, and A is here. Let's say B is here. and small b, c, and small c. Okay? So let h be the altitude. So let h be the altitude through the point C. This is a picture. Okay, so sketch. So what do I want to draw? The first picture, I want you to consider if the condition A is smaller than H. Okay, let me use a different color. So A is smaller than H. So point A is right here. And this is C. And this is B. This is angle C. And this is H. A is smaller than H, which means the A is too short. See, your side A is too short. It does not close a triangle, right? Can you see? We cannot form a triangle because the A is too short. It's smaller than H, so it's too short. Therefore, triangle possible, none. No such angle exists. Okay, so this is the first case. This A is too short. We cannot close a triangle. And then the next case is when A is exactly equals to H. Well then, so we have angle A, this is B, and this is C, and H is A. Well, in this case, we have a right triangle. So we have 1, and this is a right triangle. So far, so good? Okay, so now, let's say A is bigger than H. So now A is longer. Well, when A is longer, okay, so imagine this is B and this is C, and here this is H. A is longer. Well, when A is longer, then you have two possibilities. Okay, you can have this possibility, or you can have, okay, so let me draw another picture. So H is right here, and now your A is here. Let me make it smaller. This is B, this is C, and this will B. Okay. So A is longer than H, well then your A could be like that or like that. Can you imagine, everybody? So in this cases, we have two triangles. Okay, so what I'm doing here? Sorry. I don't mean to draw them in the same and different picture. I want to draw them in a one picture. So yeah. So A could be on the left, on the right. So here we have two such triangles. Okay, so the angle B. Yes, you can have this triangles and this triangle. So we have two of them. And then the last condition, I want to say, okay, A is so big. It's even bigger than B. Okay, well then your A is like here, and then your C is here. This is your B, and then your A. So this is H. A is even longer than B. So therefore, we can only have one such triangle. So far, so good, everybody? Yes. If A is too small, too short, we cannot close the triangle, so no such triangle exists. A is exactly equal to H. We have one right triangle. If A is too is like so here this is longer than H, but it's less than or equal to B, right? Then we can have this picture. And if let me think about it. Less than. Okay, sorry. It must be less than B, because to have two triangles, you want to have like this side and this side. And then if your A is longer, then if your A is longer, then your triangle is more like this. And you cannot have A equals to B, because if A equals to B, you just have a line, you don't have a triangle. You see what I'm saying, everybody? Mm-hmm. So that's why we require A is less than B. And then this picture, A is greater or equal to B. Yes, greater or equal to B. Okay, so they could be equal. Then you have this side equals that side. All right. So yes, the one on my notes, okay, on my online notes, I missed the equal sign. So put the equal sign. Any questions about those cases? All right. So that's why this is ambiguous. We don't know which one. It really depends on how long the side A is. Okay. How about, so these 4 cases is when A is acute. How about when, by the way, what's acute angle? Less than 90 degrees, right? And then when A is obtuse, let's draw the picture. Well, A is obtuse, so A angle A obtuse. So it's so long, right? Okay. Condition. So this is the B and then your A, right? So if A is less than or equal to B, we don't get a triangle, right, everybody? If this is too short, you cannot close the triangle. So yeah. Okay. So but if A is bigger than B, then you can have, this is the B, this is A. A is longer than B. Then this is the C. This is small c. This is what? This is B, and this is small c. Okay. Yeah. So we can have one such triangle. Does this make sense to you? Mm-hmm. So this is ambiguous. We need to draw the picture to figure out which case. All right. So therefore, let's see example. Solve both triangles formed below. So the relationship between the angles on the horizontal leg can be visualized when both triangles are drawn on top of each other. Notice the isosceles triangles. Okay, here we have let's say this is angle A, and let's say this is point C and this is point B, and let's say this is point D. Okay, so this picture is like A is an acute angle. By the way, it's 50 degrees. So put a little circle to indicate this is degree. So this is the picture here. Yes, everybody. So you can see we have 2 triangles. All right. So we want to solve. So we want to find, what are we looking for? We want to, so this is like A, right? A is 2.5 centimeters. And we know this is like B is 3 centimeters. So we're looking for the angle C and B and this side. Okay. And this side. All right. Let's see. Okay, let's separate those triangles. Okay, let's draw this triangle. This is A, this is C, and this is B. This is little c, and this is little a. Little a is 2.5 centimeters. A is 50 degrees. B is 3 centimeters. Okay, so write down the law of sine. So sine A over A is sine B over B is sine C over C. Sine A. Sine A. Let's see here. Sine A is 50 degree, right? Over A, what's A? 2.5, okay? Equals sine B over B. B is 3, right, everybody? But we don't know the angle B yet. Sine C, we don't know the angle C. And we don't know the side C. Yeah, everybody? Okay, now let's continue. We want to solve for B. Okay, so let's find B first. What did B says? Oh, they're using sine B. Sine B is, we want to solve sine B, so we both sides multiply by 3. Yes? Okay, so we find sine B. Multiply both sides by 3. Okay, plug in your calculator. What do you get? Give me 6 decimal places. What do you get? Yeah, everybody plug in your calculator. What do you get? Give me 6 decimal places. Anyone? Point what? 9? 253. Thank you. Okay, so then B is arcsine. Okay, arcsine of 0.919253. What do you get? Arcsine. How many degree do you get? 66.182 degree. Oh, A1? A2, okay. Oh, no, 1? Oh, okay, 66.82. Okay, I see. All right. Oh, then you say, it looks like this point B should be an obtuse angle. But my sine is give me an acute angle. So what's wrong? Okay, if you can remember the inverse function. So inverse function, we look at the sine. Yeah, sine is a wave. It starts with 0, right? So this is y equals sine x. And then to get an inverse function, we consider the piece that is 1 to 1. So that is negative pi over 2 to pi over 2. And then we do the refractions over the line y equals x. Then we get the inverse function. Well, the inverse function looks like that. Okay, that's why the inverse function only covers from minus pi over 2 to pi over 2. Therefore, if you know your angle is an obtuse angle, then, okay, so since B is an obtuse angle, bless you, okay, then we know that that's not my B. My B should be pi minus that, okay, so pi minus this 66, by the way, pi is 180 degree. So 180 degree minus 66.82 is 113.18. Thank you. Okay, why is that? Okay. So inverse function is like, oh, I know my y value. My y value is 0.91 something, and I want to find the x value. Do you see? These are my x values. Okay, is this point and this point. But the inverse function can only help me to find this point. Well, but then I know my point B is an obtuse angle, so we want to find this point. Therefore, this guy is going to be pi minus this angle. Can you see from the picture? Yeah, that's why this angle B is 113.18 degrees. In this picture, we know this is called the alpha. Okay, so in that picture, we know that's the alpha. And in that picture, then we know the theta. You see the theta is actually the supplementary angle of alpha. Therefore, the 66.82 is actually theta. Is that okay, everybody? Good. Now, how about the angle C? Well, the angle C in this case is what? 180 degree minus 50 degree, and minus the angle B is 113.18 degree. What do we get? 16.82 degree. Yes, everybody? And then, all right. So this is 16.82. Yeah, so 16.82 degree. Then we can find the size C. Yes. Let me use a different color. Okay. So from here and these, we can find the size C. Okay, because the angle C is 16.82 degree. So now, small c, well, you can do cross multiply, right? Cross multiply. Small c times sine 50 degree equals 2.5 times sine 16.82 degree. So c times sine 50 degree is 2.5 times sine 16.82 degree. And we want to solve for c. That's why both sides divided by sine 50 degree. What do we get? Give me 2 decimal places for the degree. Let me see. Oh, this is sine. Okay, sine. Yeah, give me 2 decimal places. What do you get? 0.94, and then 7 centimeters, like that. Yes. Oh, okay. All right. So this is the size. This is the size C. So far, so good, everybody? Okay, and then, so you can do the similar things with the other triangle. Okay, so with the other triangle, oh, ran out of space. But you can imagine with the other triangles, okay, you have A here, now your B is here, C is here. This is 50 degree, and this is 3. And this is the C, and this is the 2.5. Well, in this case, do you see your B is an acute angle? Right, everybody? So your acute angle is 66.82. So this is now 66. So this is 66.82. Then you can find the C is 180 degree minus 50 minus 66.82 degree. What do you get? do you get? The process is the same, right? And instead of here, we know B is the obtuse angle. Here, B is an acute angle. That's why this is our B. Okay? And then we can find the C by 180 minus 50 minus 66.82. What do you get? Put in your calculator. What do you get? 63.8? 18. 66.18? Oh, 63.18. Thank you. Great. So that's the angle C. So now you plug in your angle C to be 63.18. Then you get your small c. See? Your small c. Here, you replace this angle C by 63.18. So 2.5 times sine 63.18 degree over sine 50 degree. What do you get? Plug this in your calculator. See, the solution process is almost the same, but replace the angle C by 63.18 degrees. What do you get? Right, put into your calculator. What do you get? 50. Sine 50 degree. Yeah, what do you get? 2.91. Thank you. Yes. So we solve the triangles. We solve both of them. Right, everybody? So draw the picture. Write down the law of sine and put your known values there and figure out what are the known values. Okay, so okay. Alright. It's just when you find the angle and do the arc sine, make sure your angle is acute angle and obtuse angle. Right. Okay, so let's continue. So this problem, given two sides and an angle opposite one of them. Okay, so let's see. Let's give it some names. Okay, let's call this is A and this is B and let's call this C. You can name them differently. You can call this is A, this is B and C. So up to you. Just yeah, put some letter there. Okay, but the side opposite to angle A is always A. The side opposite to angle B is small b. So therefore, what are the unknowns? We know angle A, we know the side B and A. The unknown is the side C and the angle B and C. Okay, so write down our law of sine again. Put down the known values. So angle A is 98.1 degree. Side A is 5.7. Angle B, we don't know. Side B, we know 4.2. Angle C, we don't know. Side C, we don't know. Is that okay, everybody? So first, these ones we all know, right? But see, sine B we don't know. So we can find sine B first. Right, everybody? Sine B. Ooh. What's sine B? Do you see? To solve sine B, it's just like both sides we multiply by 4.2. Can you see that, everybody? Yes. So we have sine 98.1 degree divided by 5.7 multiplied by 4.2. What do you get? Give me 5 decimal places. do you get? 0.7249. Thank you. Then angle B, arc sine, right? Arc sine of 0.72949. What do you get? Give me 2 decimal places for the angle. 46.84 degree. Thank you. See, this is the angle B. What do we want to find next? We know angle A, we know angle B, then angle C, exactly. So angle C is then 180 degree minus 98.1 minus 46.84. Oh, what do we get? Thank you. So this is the angle C. Aha. See? We know the angle C. Angle C is now 35.06. Then we can find the side C. Okay? So we use this expression and this expression. We do cross multiply. You see, C times sine 98.1 degree equals 5.7 times sine C. C is 35.06 degree. Yes, everybody. So yes, C times the sine 98.1 degree is 5.7 times sine C is 35.06 degree. And in order to find the C, oops, with both sides divided by 98.1 degree. Okay. So what is C? Put this in the calculator. What do you get? 3.31. Thank you. Yes. So that's our answer. Okay. Yeah. And notice that we cannot use the Pythagorean theorem because this is not a right triangle. Okay. All right. Okay. Keep going. Okay. Word problems. Suppose you measure the angle of elevation to the top of a building to be 48.2. Okay, so we have a building right here. So this is a building. You measure the angle of elevation. Okay, so you're standing right here. The angle of elevation is 48.2 degrees. And then you step back 52.7 feet. Oh, okay. let me stand here first. At first, I ran out of space. Yeah. Okay, let's say this is 48.2 degrees. And then I step back 52.7 feet and measure the new angle to be 37.9 degrees. What is the height of the building? Okay, see, we can use this measurement to figure out how tall the building is. So far, so good, everybody? Alright, so let's give it some names. Okay, so let's give it some name. That is, let's use, this is the angle A. Let's call this A. This is A. And this is, let's say, this is O. And let's say this is C and this is B. Okay. Of course, you can call them different letters. Okay. I just okay. We're looking for the height of the building. Okay. So how do we find the height? Well, this is the triangles, right? Okay, so let's see. All right. AC. Okay, so first step, we want to find AC. Okay, let's see. So step 1, we want to find AC. Why is that? Because after you find AC, then step 2, you see, you have your H and you have your AC. So this is AC, this is H, and you know that angle. So this is the hypotenuse. This is the opposite. And you know this angle, opposite over hypotenuse, is the sine of this angle. Right, everybody? You can use it to find it. But how do we find AC? Well, okay. Look at the triangle OAC. Okay, so look at the triangle. Step 1. Look at the triangle. Bless you. Oops. Look at the triangle OAC. So OAC. This is like small a. That's 52.7. The angle O is 37.9 degree. And okay. Here we know this is 48.2 degree. So what is this angle? Do you know this angle and this angle, they are supplementary angles? Can you see that? Therefore, this angle OCA equals 180 degree minus 48.2 degree. And what is that? That is 131.8 degree. Thank you. Awesome. So what is our angle A? See, our angle A now equals 180 degree minus 37.9 degree. And minus this angle OCA, which is 131.8 degree. That is 10.3 degree. So far, so good, everybody? I don't like, okay. I figured out a problem. Let's don't call it angle O because it looks like a 0. You don't want to do sine 0. So how about let's call it D? Okay, let's call it D. D is better. You don't want to like O. O looks like 0. Okay, so let's change this angle D. Angle D. Yes. Sorry about that. Okay. All right. Now we want to find AC. You see, AC is the side opposite to D, right, everybody? And we know the angle A, and we know the side opposite to A is 52.7. So we use sine A over small a is sine angle D over the side opposite to D is the side AC. Is that okay, everybody? All right, plot in. Angle A. Angle A is 10.3 degrees. Side A is 52.7. Angle D is 37.9 degrees. Side AC, we're looking for AC. Okay. So far, so good, everybody? All right, cross multiply. You see, AC times sine of 10.3 degree equals 52.7 times sine of 37.9 degree, right? Aha, so AC, both sides divided by sine 10.3 degree. What is AC? Plug this in your calculator. Okay, give me 3 decimal places. What do you get? Yeah, put this in your calculator. What do you get? Oh, 54. Thank you. Awesome. So now, what is H? Okay, good. Now we can look at the right triangle ACB. AC is 181.054. H is right here. Angle C is 48.2 degree. Now you see, sine of 48.2 degree is the opposite, which is H, over the hypotenuse, right? So 181.5054. Therefore, H equals both sides multiplied by 181.054. What do you get? By the way, do you know your calculator has the answer key? So you click answer and then multiply by sign of that. Then you don't need to type that number again. What do you get? Thank you. 0.97 feet. Yes, that is the height of the building. So far, so good, everybody? Okay, so this is law of sine. And there is another method, which we don't need to use law of sine. We use those two right angle triangles. The method 2 is posted on the notes on our course website. Because we don't have enough time, so I will let you to read the notes for method 2. Okay, and then, yeah, let's continue. Area of a triangle. Yeah, because we don't have enough time, I would like to go over the notes with answers with you. So 8.1 notes with answers right here. Okay. All right. Yes, this is the method 2. Okay, you can watch the notes at home later. Okay, so area of a triangle. We know area of triangle is 1/2 base times height. Is everybody okay with that? 1/2 base times height. But here, look at this triangle. Look at the right triangle ACD. You see opposite is H. So opposite over hypotenuse B equals sine A. Sine A is H over B. Therefore, H equals B times sine A. So area, 1/2 base. Base is C times H. So H is B sine A. Therefore, 1/2 BC sine A. Okay? And you can see the side and the angle. The side is B and C, and then the angle is the remaining one, A. So 1/2 BC sine A, or 1/2 AB sine C, or 1/2 AC sine B. Oh, typo. Okay, typo. 1/2 AC sine B. Maybe I copied it wrong. Okay. Yes. So you see the pattern, everybody? Yeah. So find the area of a triangle having two sides of length 90 and 52, and then include the angle of 102 degrees. So yeah, area is 1/2 AB sine C. So 1/2 times 90 degrees times, sorry, 90 not degrees, times 52, and then times sine of the angle between them. So we got, this is the area. Okay, everybody? So it's two sides, 1/2 the two sides times the sine of the angle between them. And this is a word problems. Okay? The course for both rays start at a point A and proceed in the direction south, 52 degrees west. So go south and then rotate 52 degrees to the west. So this is the angle. To point B. And then in the direction south, 40 degrees east. So south, rotate 40 degrees east. And we get to point C. And then finally get to point A. So point C lies 8 kilometers directly south of point A. Approximates the total distance of the race course. Okay, therefore you saw the triangle, so you know A is 52 degrees, and then this is 40, therefore this is 50 degrees, and then you can also figure out this is 40 degrees because those are parallel. This 40, this angle equals this angle for parallel lines. And then you can find this angle B. And then you can plug in your law of sine to figure out the sine A and sine C. And then the length, which is the sum of all those three sides, you get this answer. Okay, everybody? So yeah, don't forget to do the quiz. And yeah, come to my office hours or the study session tomorrow. Bring me your notes for the extra credits. Okay, have a nice day.